Praveen sir.
Then we can start. എങ്ങനെയാ?
Sir, we can start, sir.
സാർ അല്ലെങ്കിൽ ഒരു 2 minutes കൂടെ ഒന്ന് നോക്കാമോ? ഒന്ന് നോക്കിയിട്ട് പാർട്ടിസിപ്പൻസ് ഇപ്പോൾ ജോയിൻ ചെയ്തുകൊണ്ടിരിക്കുന്നത്. സോ ഒരു 2 minutes. 2 minutes, sir.
Okay, okay. Can you see my slide? In full screen?
Sir, no slide. No, sir, it is not in the full screen slide.
Okay. So I'll put in the share screen window. That is window or entire screen? Window is there as well, sir, as
window.
Entire screen. Window, okay, window.
Then select the PPT, sir.
Yeah, I will open. Yeah, that PPT is there. Share. Then full screen.
No, sir. No.
Same. Yeah, same. But showing full screen for me.
No, it is not in the full mode, sir. Full screen, no.
Yeah. But for me,
Sir, can you select slideshow and
yeah.
And start from current slide.
I'll do one thing. I'll put in the share. Then I can see screen, window, or tab. In that, Chrome tab, window, and entire screen. You can see entire screen as well as window.
Yes, sir.
Which one, entire screen or window?
Sir, if you're comfortable with screen means no issue. You can share the screen.
That is entire screen.
Yeah, entire screen. Otherwise, you can take the window, sir.
Yeah, window.
And in that window, you can select the PowerPoint.
Yeah, I can see the share.
Yes, sir. That's it.
Now, full screen.
Okay.
Is it okay now?
No, sir.
Sir, can you see that slideshow option there? Slideshow.
Yeah, I'll take the slideshow.
From that
slideshow from beginning.
Left-hand side
from
corner.
Beginning.
Yes.
Is it moving? Slides?
Slides are moving, but not in full screen.
But again, it's full screen for me. I think same issue happened previously also. There. Window. ATAL. Then slideshow from the beginning. No, again, same problem.
Sir, sir, can you try sharing the screen?
In the entire screen, okay.
Yes, sir.
That option, okay. Stop sharing. Now share. Entire screen.
Yes, sir.
Is it okay now?
Sir,
still that.
No, sir. No. Now it's okay. Now it's okay.
Now it's okay.
Now
Yeah,
it's okay.
Sir.
Fine.
Just wait. I'll put on the video also. Video camera, okay. Mic is also okay. Is it okay now? Full screen?
Yes, sir. Yes, sir.
It's okay, sir.
Yeah.
Now it's okay.
Yeah. So can I start?
Okay, sir. Then we can start. Once again.
Yeah.
Ma'am, Angela, ma'am.
Okay, sir.
Okay, we can start the meeting, ma'am.
Okay.
Good evening, everyone. Welcome to day 3 of our session. It's my pleasure to introduce our distinguished resource person for today, Dr. Suresh Kumar. Dr. Suresh is a professor in Department of Electronics and Communication Engineering at the College of Engineering, Trivandrum, under Government of Kerala, a position he has held since 2019. He has not only made a mark in academics but also excelled in training and motivating diverse teams. Dr. Suresh holds a PhD from Jadavpur University, Kolkata, and MTech from NIT. His contributions to research are remarkable, with over 16 papers published in reputed journals and 27 in conference proceedings. We are truly fortunate to have someone of his caliber and expertise with us today. Let's give a warm welcome to Dr. Suresh Kumar, and we eagerly look forward to learning from his wealth of knowledge and experience. Over to you, sir.
Thank you. Thank you, madam. Good evening, good evening, all the participants. So the topic for this AICT teaching and learning program, FDP, is environmental impacts of renewable energy. So such subjects, please try to understand why AICT is giving sanction for such programs. Engineering content is comparatively less in this. Still, AICT is valuing this. The reason is, we will see one by one what is the relevance of such environmental impact topics in the real engineering arena. One by one, we will see. Before that, the left side, you can see the word EPEAT. Is it EPEAT? Its full form is Electronic Product Environment Assessment Tool. Electronic Product Environment Assessment Tool. Nowadays, there is a standard globally for any product, not only electronic products. There should be a standard protocols. Accordingly, we should design. That is Electronic Product Environment Assessment Tool. How the environment impacts affects the system, as well as how the system makes the reverse side on the environment, dual, both side. Environment also affects, environment makes the products characteristics to change. Similarly, reverse, product or system or electronic devices also affects in many manner the environment. Whenever we are talking about renewable energy, mainly we are considering wind turbines as well as solar photovoltaics. Even though other sources are there, even mini hydro projects, biomass, tidal projects, many things. Main sources are solar photovoltaics as well as wind turbines. We will see some interesting aspects in this. The tragic thing you can see, the birds fly past wind turbines. Okay, the death casualty, the mortality is the issue. You can see the birds flying there. Mortality is one of the major issue when we are commissioning this wind turbines. Please note that it is not commissioning in the metro cities or towns. It is far away from cities. That means it will affect our habitat. One of the issues is this casualty. Then, as I told earlier, the habitat loss. Renewable energy facilitates can take up. First thing is huge land usage, space, even agriculture land or forest, so which can harm or displace wildlife. So it's one of the major issues affecting wildlife and occupying space. Not only that, when we are commissioning a solar plant or a turbine, wind turbine, we need to construct a road. So it also affects the habitat. Second, land damage, that is re-engineering of land. So such constructions, buildings, this renewable energy plants, wind turbines, related roads, it can damage the land's natural layout and destroy plants. So it's another environmental impact. Then naturally, air and water pollution is a major issue. So power plants can contribute to air and water pollution during their installation, maintenance, and decommissioning also. Not only commissioning, it is very easy to commission any system. It is very easy to commission an aircraft carrier or a submarine, you know that. But decommissioning is very, very critical in terms of environmental impacts. So many hazardous gases, such issues are there. So at the time of installation, as well as while it is maintaining and while decommissioning, these are the issues. Nowadays, we are not at all bothered about decommissioning issues of solar panels because the lifetime of a solar panel, it's also a renewable source of energy, around 30 to 40 years. And for the last 20, 25 years only, there was a boom in the industry. So now we are not at all thinking about the decommissioning. But you consider another 20 to 40 years, the decommissioning, e-waste will be a problem. Nowadays, e-waste means in our mind only the mobile phones, a laptop, say olden days, the TV, CRT model, cathode ray tube type TV, LED TV, such things. Other electrical waste also. But future, one of the major contributor of e-waste will be solar photovoltaics. Within another 20 years, this will be a crisis all over the world. Then another interesting thing is noise pollution. Almost all power plants, except solar photovoltaic, which is silent, it produces noise during installation, operation, and maintenance time. I think most of you are familiar with the area Muppandal in the Kanyakumari district of Tamil Nadu, Muppandal, where large windmills, wind farms you can see. So if you are going very close to that, there will be, you can feel the noise production. And the other issue is visual effects. In a shiny day, when the wind turbines are rotating, it actually irritates our eye. Okay, even may cause headache for the persons who are watching this. Similarly, concentrating solar power, it can also restrict the, see, not only that, such high altitude, that's wind turbines, as well as concentrating solar power, it can restrict the movement of planes, and on the marine side, sea freight also. Another major problem, most important engineering problem. So far, we thought it is something humanities topic, but now we are moving to engineering area, that is use of hazardous materials. That is manufacturing of solar panels can use hazardous materials. Now we are generally we are saying that solar photovoltaics is a green source of energy. It is believing, but actually it is not so. It is like a person who committed murders some 20 years back, some 5 peoples, and now he is a devotee and saying that I'm always praying to God and like that. But his past, he committed killing 5 people or 10 people like that. Now solar is, we are saying that it is clean energy, green energy. But you imagine for 1 gram of electronic grade silicon, how much metallurgical grade silicon is required. From 1 kg, 1 kilogram of metallurgical grade silicon, that is MGS, metallurgical grade silicon, we will get a few grams of electronic grade silicon. Remaining is waste. That is for simple devices. So you imagine if we are totally changing from fossil fuels to main 2 power sources, that is solar photovoltaics as well as wind turbines. Imagine the waste. Okay. E-waste means after production, even before production. That is the raw material side also, there will be huge waste. Most of them have radiation nature also. So that's the engineering aspect of this topic. Then disposal of toxic materials. It's very dangerous. Solar panels can contain toxic materials that need to be disposed properly. And nowadays, whenever we are saying, using the word solar panel, what is in our mind is just in a house, just a small solar panel. That's in our mind. But soon, even already started, we are connecting solar panels to the grid, national grid. So many issues are there. So in solar panels, this toxic material is one of the issue at the time of operations, as well as even before, when we are converting metallurgical grade silicon into electronic grade. And disposal is a major issue where we will dispose. So imagine after 30 to 50 years, what will be the situation? Next is land use. Long-term land use can diminish the effectiveness and fertility of the land. As I told earlier, the lifetime of a solar panel is around 30 to 40 years. Nowadays, up to 40 years return on investment time. So 40 years continuously we are installing a panel. Somewhere means around 40 years, the land will change. Its effectiveness and fertility of the land will change. Even after decommissioning, we can't use that land. That will be almost a wasteland. Now, other environmental impacts we will see. The materials used in creating renewable energy installations include neodymium, see this, neodymium, dysprosium, cadmium, very dangerous, tellurium, gallium, indium, and even selenium. So these materials have been used recently, which means that there are limited or no recycling systems yet. That's why I told previously. Now we are not at all interested, but in another 10 years it will be a concern. That is, there are limited or no recycling systems yet. The reason is these materials are started to use recently. So we are not bothered about its impacts. But within another 30 years, disposal will be again a concern. When we are buying an LED TV, there is no concern, we are happy. But when you want to dump it, the concern starts. When you are buying commodities in a plastic carry bag, we are happy. But at the time of disposal, the issue comes. So a solution to facilitate the large scale recycling, large scale it is. Even our home, in our home or single town, we can't control it. And there the nation wants to address such things. The recycling of those materials need to be designed to avoid such problems in the future. That's why the subject itself, I think your title of the FDP itself, the word sustainable is there. During BTech studies, even BTech students are giving less importance to the subject. They think that nothing study, just right at the time of examination. But how many of them actually know the word, meaning of the word is sustainable? Sustainable means, okay. So
Suresh sir, can I check the mic? Sir, mic ഒന്ന് check ചെയ്യാവോ?
Sir, you are not audible. Can you check your mic, please?
Right hand side drop.
is it okay now?
Yes sir, yes sir, yes sir.
Just wait, just wait. Can you see the full slide, full screen?
Yes,
Yes
sir.
sir. Yes.
Sir.
Okay. So sorry for the technical issue. And this is the
Actually,
problem
it's
with
not yours, not your fault, sir.
yeah. This is the problem with actually the online talks compared to offline talks. There won't
Yes
be
sir, yes sir.
much
We have
interaction
understood.
between the audience and the source person.
It happens.
Okay, so I will once again talk about this slide. That is, the materials used in creating renewable energy is a concern. That is, recently we started to use neodymium, dysprosium, cadmium, tellurium, gallium, indium, and selenium. And this is recently only used. That means we don't know the output. What's the hazardous issues? Because there are limited or no recycling systems now. Now imagine after 20 or 30 years when there is a return or when there is a decommissioning, think this system, then absolutely this will become an engineering problem. So far it was thought about an environmental issue, but at that time it will be a concern of the engineers, because sustainable engineers, I think already I stressed the definition of sustainable engineering, but due to mic problem, I think some of you have not heard that. I will repeat. A system is called sustainable when three conditions are met. One is it should not be harmful to the society. Second, it should not be harmful to the environment. Environment means animals, plants, birds, everything will come into picture. Third, it should be economically viable to the nation. Economically, not technologically, economically viable to the nation. When these three conditions are meeting, we will say that the system is sustainable. That's why in beta curriculum, we introduced the topic sustainable engineering, as well as the idea of design for DFX, design for anything, design for even safety and other aspects, design for environment and all those. Again, the greenhouse gas issues, in hydropowers, it occurs when the reservoir is created for a hydroelectric dam. We are creating a huge reservoir. That means flooding of land. From there, during rainy season, actually that flooding causes the land, causes organic matters to decompose, like methane, carbon dioxide, etc. But compared to fossil fuels, it is less. So hydropower still has small carbon footprints due to these reservoir emissions compared to the fossil fuels. Now we'll address a little bit about the solar panels. Parallelly, I will go with the solar panel as well as wind turbines. In solar panels, actually they designed to absorb the sun's rays. The solar energy does not produce at night. That's one of the issues. Solar energy does not operate at night without a storage device, as well as during cloudy weather conditions. It may lead to unreliability of the system. So most of the time, we're planning about a hybrid system, wind turbine as well as solar, a hybrid with the storage. So solar energy remains useful, but we need further research to maximize its benefits. At the same time, we should overcome all these negative impacts. This is the solar radiation spectrum. Nowadays, we are focusing in the spectrum of 400 to 600 nanometer spectrum, that is visible light. Even for visible light conversion, energy conversion, we need this much hazardous materials. But to improve the efficiency and to make the devices cheap, more cost effective, we are planning to take more bandwidth. That means beyond 400 to 600 nanometers, further area, that is ultraviolet as well as infrared region. Then we need special grade hazardous materials. Then problem will double. So within another 20 years, there will be 3 times more e-waste from this industry alone. So previously you have seen air pollution is one of the issue. Then it may cause climate change, then water pollution, then thermal pollution, that is especially with the solars. Then as I told earlier, solid waste disposal is the issue. Now, at the same time, we will see some positive aspects. As you know, the positive aspect is reducing carbon dioxide emissions. That's a positive one. A safer air we will get. That's only positive thing. Now we'll see the environmental impact and the risk assessment. There is an engineering term, risk management, risk engineering, risk analysis. So risk evaluation or risk assessment. For any project, first we should see whether the project is technologically feasible for the nation, technologically. If technologically feasible, whether it is economically feasible. If economically feasible, then is there any risk we should assess? So economic feasibility approval will be from the government, but technology feasibility will be decided by the organization. And the risk assessment will be by environmental agencies. What are the negative effects on the environment throughout the life cycle of the renewable energy process? Not only at the time of commissioning, that is throughout the life cycle of the renewable energy project, that is at the time of construction, then at the time of operation, then decommissioning is a major issue. Decommissioning is not an easy task. So at the time, you should consider the land use, wildlife disruption, that's another issue, wildlife disruption, water usage, even for cleaning a solar panel, even for just a small 1 square meter solar panel, we need sufficient water. So imagine, actually best method to clean solar panel is water. Then visual impacts, that is from solar panel as well as wind turbines. Visual impacts, it may affect our eye. Then emissions associated with at the time of manufacturing, there will be hazardous gases emission at the time of installation, everywhere. The technology itself causes some impacts. These are the issues, engineering issues to be addressed. You can see this figure, you see. It's almost like you will use the word no man's zone, like that, no flying zone actually, just like flights. Nations may impose ban on flight, no flying zone for flights. Similarly here, no flying zone for birds, but bird don't know. So most of the time, the birds fatality will be more at such places. So the habitat losses. So the impact of wind turbines on wildlife is concerning, since there have been fatalities among birds and bats. This is one of the major concerns, because the rotating wind turbines, that blade, the rotating blade of the turbine, it challenges the environment with their noise and vibration. One is its noise, second is its vibration, third is the fatalities among the birds and bats. I will show some case studies later. So one of the negative impact is threat to the birds and marine creatures. At the same time, we are commissioning such plants, there's wind turbines in marine environment also. The impact of wind turbines on birds and marine creatures remains a concern. There might be an occurrence of collision of birds, just like a flight collision, there will be collision of flights, like flights, the collision of birds with rotating blades results the fatalities, a major issue. Offshore also same thing. Offshore wind farms do negatively impact marine habitats. Okay, since the support structures and subsea cables pose collision risk for marine creatures. This is another major issue on marine side also. Another thing already I've seen, noise pollution. Wind turbines can produce noise and impact the community's health. We are happily enjoying the power from turbines, wind turbines. But if you are going to Muppandal area, the people are suffering, okay, with all these issues. So noise generated by the vibration and movement of turbine blades is of aerodynamic nature. That is the thing. So it affects directly to the health of the human being. Then shadow flicker is another issue. Such a giant turbine, the morning as well as at the time of evening, that flicker will be there, shade, its shadow, and a flickering effect when it rotates. So even people can't walk close to that nearby areas. It may irritate their eyes as well as they may cause headache and such problems. There are a shadow cast on the ground when wind turbine blades are rotating. The repetitive nature of this shadow creates a flickering effect. It will be as good as an LED bulb, LED torch is continuously switching on and off after focusing on our eye. So as I told earlier, during sunrise and sunset, it will be a tedious problem for the people. So this shadow flicker affects visually and can cause health-related issues. Now we'll see some case studies. One is at Gadak district of Karnataka. You see how many wind turbines are there? 750 wind turbines in just 4,656 square kilometers by 20 companies. Okay, just 4,650 square kilometers, 750 wind turbines. You will see the effects. There is 5 taluks. Gadak taluk with the highest number, 413 wind turbines in 21 villages. This 21 village people are suffering with the same issue what I told earlier. 413 wind turbines. Imagine. Okay, we'll continue. So in that Gadak district, as per the survey of 2016, that Gadak district alone, the geographical area 1097 meters and installed number of wind turbines 413. Then percentage share of wind turbines out of the total, it's 55. That means compared to other districts, you can see Mundaragi, Nargund, Ron, other villages. So the deforestation is the issue there we are observed. Actually, that area are surrounded by forest, but deforestation is the issue there. So one of the major issue with the solar panels, as well as solar panel means not the solar panel what we are using for one bulb in our home, for the automatic light or something, or what you are seeing on the road, a solar light, not that. A large, huge project that is grid connected solar photovoltaics. Ours is off grid. The other one is on grid, huge one. So deforestation, again, for wind turbines also same issue. Deforestation is quite common, while installation of the turbines in the hilly or forest area. Never we can commission this on city or town or near road. So it will be always on hilly area or forest area. Naturally, deforestation happens. So which affects all plants, animals due to the construction of roads to wind turbine sites. And vehicles wants to move to wind turbine sites, the employees and all this. So there will be roads. Definitely it will affect the animals and plants. Plants means sometimes this rare species also will be there. Okay, the installation of wind turbines in agriculture area, it's a major concern. Already we have very less agriculture land. Installation of wind turbines in agriculture land is not acceptable, which is a serious issue from the environmental point of view, as well as birds and bat mortality scale is another issue. It should be reduced. Okay. You see again the same taluk, Gadak, turbines, agriculture land in acres. You can see that agriculture land in acres 353. That is number of turbines. Land is 179.5 acres land. 179.5 acres of land. It will be approximately 4 engineering colleges campus, for 3 to 4 depends. Then barren land, hilly area, even forest. Forest they are not occupied, but that Mundaragi occupied 107 acres of forest also for just 214 turbines. So this is the survey shows. When you are converting, you can see around 52% of the land, agriculture land is occupied. And barren only 1%, hilly around 18%, and forest 29%, major issue. Neither we can acquire forest nor agriculture land. Then what we will do? If you are taking hilly area, the re-engineering of the hill area will be another issue. The barren is again a problem. So where will be the exact location of solar power plants as well as wind turbines? Utopian environment. It's called technically or engineering ways, you can call it a utopian environment. This environmental impact study that's in Kerala, the place well known to people, Attapadi. That is study of the potential environmental impacts of wind farm development in Agali Taluk, Attapadi, Kottathara, and Nallasingham areas of the Palakkad district. Palakkad district as well as Attapadi. That means Silent Valley and National Park. Definitely the species, birds will be rare. So that is the impact on the birds. The study was by Center for Wind Energy Technology, Chennai, by Dr. Arun PR and Rajan P. That is, bird collusion is mostly seasonal there, local as well as migratory birds. That's another issue. Migratory birds are or can get impacted due to their daily movement around these turbines. Infant mortality is too much there. In Attapadi area alone, there are many fruiting plants. That's major issue. In Attapadi alone, there are many fruiting plants, especially that ficus available. So what will happen? Naturally, birds will attract to that place. But even 75% of the birds are dying. Some places, 75% is the casualty of birds. And we cannot avoid that fruiting plants. So these fruiting trees attract birds from neighboring places also. These movements can also cause the bird collision at wind turbines, and especially in Attapadi means a rare species. But we have no other way. We can't commission in Cochin City or Trichur or Trivandrum. This is what ficus trees. So naturally, the birds will be attracted there and may cause an increased risk of bird movements in some of the turbine sites. This is the reality. Here you can see a total of 152 species of birds were reported so far from Attapadi Hills, which in that 15 endemic species out of 24 in the Western Ghats. Western Ghats is what is called a protected area, a buffer zone, actually, buffer. Even the Attapadi area itself is an unofficially informal buffer zone where 152 species are there of birds and 15 endemic species out of 24 in the Western Ghats. According to a study by Vijayan et al. In 2008, Sholayur, you heard this, Sholayur areas have more bird diversity than the Agali town and Kotatara due to the presence of intensive evergreen patches in Sholayur area, Sholayur. But unfortunately, the casualty, the mortality rate is higher there. Attapadi is considered as an informal buffer zone bordering the National Silent Valley National Park. The four main effects of windmills. One is, as just now seen, collision, then landscape changes. 30, 40 years continuously operating. Definitely that landscape will change. Barrier effects. When we are constructing roads and such things, constructions, that barrier effects, animals can't cross that. Animals may byroute the routes to area where people are residing. Finally, we will blame forest authorities. That is barrier effects. So I remember a figure appeared in the WhatsApp groups. When two people driving through forest, one deer is crossing, then one person, the driver telling to his friend that a deer is crossing the road. Then the friend is saying, deer is not crossing the road, we are crossing the forest. That's the truth. So barrier effects is one. Then habitat loss. So road construction, turbine construction, major issue, and the materials and items required for turbine construction movement. Then installation of electrical substation. We need a substation when we are connecting to grid. Electrical substation, then transmission lines. The same area, transmission lines. This will change the topography of the wind farm site. So for engineers, when generally thinking, it is so easy, construct a wind farm, wind turbine, so easy. But substation will come into picture, transmission lines, the electrical other installations will be a huge issue. You can see here a forest clearance and massive soil erosion due to the hillside cutting. That hill for construction of a road to the wind farm, windmill, it's photo by Abhishek Gavande. You can see there the massive soil erosion due to this cutting. It will definitely cause so many damages indirectly also. Recently, you have seen in the district of Wayanad so many casualties. Another thing you can see that mining activities. Okay. There also you can see one wind turbine commissioned, and left side you can see one truck is moving. That road, you can see road construction. So this is one of the issue. Now the environmental impact of wind turbines is a controversial topic, as wind energy will become the main source of energy in the near future. You know that the fossil fuels will be no more. Within another 50 to 75 years, there won't be fossil fuels. So the technology should change for wind energy. We are moving to wind energy as well as solar photovoltaics. So wind energy will become the main energy source in the near future. So many environmental effects that now seem minor may cause impacts in the future. Now we are thinking that it's a minor issue. Okay, but when wind energy itself will be the major sources of power, the effect will be very serious, according to Liang and Yang in 2012. Another thing you can see here, the photo by Narayana Swami Subbaraman. Despite of the growth of wind energy in India, little is known about how wind farms affect terrestrial animals. As I told in the earlier slides, mentioned, these photovoltaics as well as wind farms is not over 50 years or 100 years. No. So we don't know the long-term impacts as well. But one thing is sure, the new e-waste will be there. So far, e-waste, as I told earlier, we are thinking about only some electronic devices, but solar modules and panels will make a new type of e-waste. That's another issue. Now, the study by the Karnataka Forestry Department recommends that before installing turbines at a site, so it's an engineering issue, not an environmental one, before installing turbines at a site or before licensing new wind farms in forest areas in the vicinity of the forest patches or next to wetlands. Wetland, previous diagram you have seen, the wetland. There should be a critical evaluation of animal diversity. You should see the animal diversity, especially the birds and their seasonal movement. We should study the seasonal movement of animals, birds. Then occupancy and abundance of mammals and possible impact of them. We should study this, then only we can give license. So the engineering person should always refer the files to persons addressing the environmental impacts. By law, it is enforcing that new wind farms can be licensed only after studying the impacts. Critical evaluation of animal diversity, birds and their seasonal movements, occupancy, abundance of mammals and possible impacts. These small measures could support responsible wind energy development. So the new word, responsible wind energy development, like sustainable, responsible, not simply generating wind energy, responsible wind energy development in a biodiversity friendly way. Okay, by Abhay, scientist. Now we can classify that wind turbine area into four. It is called the zone of the theoretical visibility. Zone 1 means visually dominate. The distance up to 2 kilometers of the wind turbines. Visually it will dominate. And zone 2, visually intrusive, blades movement is clearly visible. If you are continuously watching the rotation of the blade, it will attract the eye, but it will be healthy. It will create a health issue. Blade's movement is clearly visible and can attract the eye from a distance of 1 to 4.5 kilometers. Those who are traveling from Nagarkoil to Chennai in highway through bus, you can see that Muppandal. There, the wind turbines you can see from large distance. If you are continuously watching that, you can feel even how it is affecting your eye. Then zone 3 is noticeable. Movement of blades is visible and the turbines appear small overall. The distance of 2 to 8 kilometers. And zone 4, the apparent size of turbine is very small over a distance of 7 kilometers. Like that, visually dominate is first up to 2 kilometers. Then imagine the people staying around this area daily, how they are suffering. Now we'll see some birds mortality in the USA, because most of the materials, there will be less study with respect to India. So easily you can publish papers if you are collecting data on from our nation, India, different states or different forest area or different places where the solar panels as well as turbines are there, wind turbines. In 2013, an average 234,000 birds fatality in 1 year. 234,000. You can see that different places. In 2014 again 291,000, and average, it's our average. And country-wise also it is available. During a study for the period 1999 to 2009, around 10 years, Belgium with 64 turbines, mean fatality rate is 16%. 16% means out of the 100% casualty of animals, birds there, 16% is exclusively by turbines. That's the meaning of this percentage. 16% means out of 100%, 16 casualty of birds is due to turbine only. This is the environmental issue. Similarly, Netherlands, you can see, Great Britain, it's comparatively less, 3.2, Norway, 0.4, Spain, 15.8, USA eastern side, 1.98, only too low, Canada, like that. Again, another study is there. That is the fatality rate of birds at wind farms up to 2017 by a study by Ragnall. That is in USA, small birds. Fatality rate is 75%, very dangerous. 75% means out of the other ways, birds can be died. Out of the fatality of birds, 75% is exclusively with the wind farms, that blade rotation. Then Europe, that songbird, 28.6. Again in Sweden, 25%, 1/4, a huge number. Again, it is graphically, you can see that Belgium, Norway, and like that, the countries. Right side, you can see the fatality rate, and left side, the number of turbines. And left side, you can see when number of turbines are more, correspondingly, right side, you can see fatality also more. That's why our concern is that since we don't want further traditional energy sources, fossil fuels, actually we want, but within 50 to 70 years may vanish. Definitely the world will move to wind energy as well as solar energy. When focusing into wind energy, we want to commission more and more turbines, correspondingly fatality will be higher. So it's affecting the species, valuable species of Earth. This is the concern. Now we'll see some solar PV system impacts also. You see, so far we never thought about this problem. So it made environmental hazard issues at the time of conversion of metallurgical grade to silicon grade, then at the time of operational period. Now, even before decommissioning, there is an arc fire. It is called arc fire. Fire again, it is a hazardous one. Even if you are decommissioning, again issues will be there. Now, the previous slide I have shown EPEAT standard, EPEAT, that is Electronic Product Environment Assessment 2. Actually, 3 grades are there: bronze grade, silver grade, and gold grade. If you are seeing our laptops we are using in India, no stickers are available either with bronze or silver or gold. Whereas European countries are strictly demanding EPEAT standard. That is, environmental assessment should be made. Accordingly, they will grade as gold marked electronic products, silver marked electronic products, and this bronze. That is grade 1, grade 2, and grade 3. Electronic product environmental assessment 2. And when referring to sustainable use of resources. But unfortunately, while we are studying in BTech, while we are taking classes for BTech in sustainable engineering, the students are not aware of such things rather than getting a grade. EPEAT is a system used to evaluate and label the electronic products. When we are exporting, assume that we are manufacturing some electronic products, definitely European countries, if we want to export, they will ask whether you have EPEAT standard protocol. Okay, evaluate and label electronic products based on their environmental impact throughout their life cycle, not only at the time of manufacturing or operational time, throughout their life cycle. Even there are protocol how to decommission that, how to dispose that e-waste. how efficiently they use resources during manufacturing, how efficiently the operation, and how efficiently the disposal, and promoting sustainable practices in electronic procurement. That's why it is a subject for electrical students as well as electronic students. Of course, it is there for civil and mechanical students also. Now, in environmental impacts, again, renewable energy installations are critical to keep global warming under 2 degrees Celsius. It's a mandatory one. And their environmental impacts should be studied as rigorously as we evaluated non-renewables, their maximum potential. Every non-renewable energy sources, we will always study their impact. Whereas there was less focus on renewable energy installations, mainly with the photovoltaics as well as turbines, wind turbines. Now see this photograph. Researchers and environmentalists advise long-term evaluations. Long-term, not short-term, long-term evaluations in important landscapes to ensure that the wind energy development is environmentally sustainable. Now we are getting the meaning of the subject sustainable engineering in BTech level. Okay. All the designs, this concept should be there. Now, some negative impacts of solar energy. Previously, you have seen turbines. Now, we will see some negative impacts of solar energy. The solar energy can have negative environmental impacts primarily related to the manufacturing process. First is manufacturing. Usually we won't see that. Second, use of toxic materials, another issue. Then large land requirements for solar farms that will disrupt the habitat, and potential water usage. That cleaning is the main issue, depending upon the technology, as well as leading to land degradation is the issue. Land degradation and disruption of or the ecosystem itself. Previously, you have seen in Silent Valley, that ecosystem is actually dying. Actually, we are doing negative things, but anyway, we need energy sources. But only thing is we can reduce the impacts after studying the impact. If we know the impacts, engineers can reduce it. Only that. Land degradation is issue and the disruption of the or ecosystem. This is one of the negative impact. Now, land disturbance or land use impacts. Solar energy facilitates require relatively large areas for solar radiation collection. If you are traveling through the highway between Kochi and Trichy, you can see Nedambasheri, Cochin International Airport. There you can see the huge area, high costly land, huge area. There will be solar panels. Okay. But they are designed cunningly and wisely, because if they want to construct new building, they will lift it up and will construct a new building, and again the same solar panel will commission on the rooftop. Okay. That's why you are seeing while you are traveling through bus or train, you can see that. But at utility scale, when you are using the solar radiation collection will be higher, that is 20 megawatt or greater. Then solar facilities may interfere with the existing land uses such as grids. Because nowadays less projects, even in Kerala also, nationally also less. But as you know, India has a vast potential for solar energy. So within another 30 years, there will be a boom in this field. That time, this will be a concern. Land disturbance and land use impacts. Then soil and water resources issue. The construction of solar facilities. When I'm saying this solar facility, it is on grid, not off grid. That is not a small power generation. See, it is to utility scale. That is to connection to grid. Okay. Large areas of land requires cleaning, grading, and results in soil compaction. Potential alternation of drainage channels. At the same time, we want drainage channels. Once you are washing the solar panels, we need a drainage channels, and increase the runoff and erosion will be there. Then engineering methods can be used to mitigate these impacts. That's why we are studying the subject environmental engineering, sustainable engineering. You should apply engineering methods to solve this. Environmentalists can only address the impacts, but solutions they can suggest. Only we can suggest the solutions also. So our design should be sustainable. That's why we are using the word sustainable engineering, green electronics, eco-friendly, and all those words. Ecological impacts. The cleaning and use of large areas of land for solar power facilities can adversely affect native vegetation. Again, another problem. Vegetation and wildlife in that area, including loss of habitat, interference with the rainfall, and drainage issues. Just now we have seen, and direct contact cause injury or even death. That is there. So casualty is there for human being also, because large solar plants there will be on a structure, but people are walking behind that. So if there is a say storm or something comes, definitely the panel will fail. There will be an accident. Now we'll see again the hazardous materials used in PV panels. What are the hazardous materials? That is, photovoltaic panels contain hazardous materials, and actually they are sealed under normal operating conditions. Total encapsulant, we will use the word encapsulant. There is the potential of environmental contamination if they were damaged or improperly disposed upon decommissioning. At the time of decommissioning, it is as good as, or like that, we are throwing a fluorescent lamp. We should carefully decommission it. We should not throw. If we are throwing, we know what happens. Similarly, the environmental contamination, they were damaged or improperly disposed at the time of decommissioning, means there will be hazardous materials which will come out. So concentrating solar power systems may employ materials such as oils, molten salts, hydraulic fluids, or coolants, even lubricants. These are all hazardous. So decommissioning, rather than commissioning, decommissioning is the major issue. Like ship, almost all nations can commission warships. Warships, most of the nations can commission, but very rare nation can decommission ships. So decommissioning is tedious task rather than commissioning. It's like our house. It is easy for a mason to construct a house, but demolishing is a tedious task. Then another thing is heavy metals. So some scientists and engineers argued that the latest technologies introduced on the market, namely thin film panels. You heard about thin film physics and thin film solar photovoltaics. Thin film, okay, nano solar photovoltaics also there. Thin film. Thin films are nowadays using for floating solar panels over dam reservoirs. Floating solar panels. Even KSCB have floating solar panel at Idiki Power Reservoir. They are manufactured using dangerous heavy metals such as cadmium telluride. So while it is true that solar panel manufacturing uses these dangerous materials, then coal and oil also contain the same substances which are released with combustion, but comparatively less. Now we are always saying that this coal and oil, this fossil fuels, oil and coal, harmful. So we are moving to solar, green energy, or eco-friendly. Actually, it is not eco-friendly. By appearance only, it is eco-friendly. By appearance, reality, it is not eco-friendly. All these issues will come into picture. The same is the issues coming with the coal and oil, that is fossil fuels. Then one by one, we will see again the environmental effects. One is energy demand. This is another interesting thing. Solar requires a significant amount of energy upfront to produce. Upfront energy. That means if we are getting, say, 1 kilowatt of power, 1 kilowatt of power into some time, some energy, 1 kilowatt hour I am taking, some energy. For getting that much energy from the solar panel, imagine how much energy wasted actually to convert that silicon grade material to metallurgical grade silicon to electronic grade, and related process, assembling, this encapsulation, panel making, and all those. How much energy was required? That energy upfront, okay, to produce. Then mining, this material we got after mining, how much energy we used? Manufacturing process, how many energy used? Transportation, we are blaming that fossil fuels are not good and solar panels are eco-friendly, but carrying on a truck filled with diesel and blaming this fossil fuels. And transportation all require substantial amounts of energy. So there should be a balance. Mining, we need energy. Manufacturing, we are spending energy. Transportation, we are spending energy. After that, we are getting a solar photovoltaic module or panel. Then quartz also we are making. Quartz also using there. Quartz also same problem. Quartz must be processed. It should be cleaned, then manufactured. Then how much energy used for that, which may come from different facilities, that is aluminum and copper, to produce single solar module. You know the difference between cell and module, panel, and all those. PV cell means it's a PN junction, special grade PN junction. Then using 6 or usually 6, that using cells we are making a module, PV module, group of modules we are making an array, group of array we are making a panel, usually 36 I think. So heating the quartz, again for processing we needed to heat the quartz. During the processing as well as stage requires very high heat. This is also energy, heat energy. Okay. So actually we are using energy to get all this. So we need from that devices we need more energy to be produced. Otherwise it's a negative one. Okay. Now chemicals, another issue. To produce a solar grade silicon or even electronics grade silicon, again renamed as solar grade silicon. Electronic grade silicon is for general electronic devices from metallurgical grade. To produce solar grade silicon, semiconductor processing typically involves hazardous chemicals. That is, these chemicals may or may not be disposed properly. This is the issue. These chemicals may or may not be disposed properly. Like every industry, especially in India, a law not enforcing so much. The flexibility of law is there. But in European nations, as I told earlier, APX standard, they are very strict. So like every industry, there are companies, not all companies, rare, some companies leading by example, and others which cut corners to save cash. To save cash, they will violate the protocols. Like carrying fish, they are not getting fresh fish. For profit or to save cash, they may add formalin. Like that, there will be established law in the motherland, but there are companies who may not dispose it properly, and companies may dump chemicals in future. Even in chemical industries in India, we know this. Companies may dump chemicals or even won't recycle. A tire, vehicle tire, we can throw anywhere in the national highway itself. Nobody will question in India. But in many European countries, will be sentenced, will be punished. We can't throw that. The company manufactured the car itself should take it back, recycle, for recycle. Okay. But for us, the tire is either for strikes, to burn during strikes, or to throw on highway itself. Now recycling. What happens when solar panels break or are decommissioned? This is the issue. Nowadays, nobody is thinking about solar panel decommissioning. Everybody wants commissioning because 30 to 40 years of life. But after 40 years, 30 years, what will happen? It should be decommissioned and a new panel should be commissioned. Then the real environmental impacts comes. Although solar panel recycling has not yet become a major issue yet, that is as on today. Solar panel nowadays we are bothered about a laptop as e-waste, mobile phone as e-waste, even plastic. Nobody is thinking solar panel. But because now it is not a major issue, it will be in the coming decades, solar panels needs to be replaced, decommissioning and replaced. Then this environmental impacts will be too much. Now currently, solar modules can be disposed of with other standard e-waste. Now we are considering it as a general e-waste compared to other all electrical, even e-waste means electrical as well as electronic waste. Along with it is considered. But in future, we need a separate rule, separate law, separate guidelines for solar module disposal. Countries without robust e-waste disposal methods means are at higher risk. That means definitely India. Countries without robust e-waste disposal means are at a higher risk of recycling. Definitely, we will face this problem because even though law is enforcing, people won't obey this, industry people won't obey this. So chances of more solar waste will be there for us in India. Now, at the time of panel manufacturing, what will happen, we will see how are solar panels made and what are the environmental impacts. Solar panels have few components. One is a frame, it is made of metal. Then cells, previously I told PV cell, backsheet, like a photo framing or photo framing backsheet is there, protective film, then conductors and the tampered glass cover, top a glass cover. The frame is made of aluminum, the cells are made of silicon, the conductors are of copper and the backsheet, and film are typically a polymer or plastic based material, polymer or plastic. Again, naturally, the issue arises. This is a general solar photovoltaic module. You can see top, the aluminum frame, glass, aluminum frame, the tampered glass, encapsulant covering this. Ethyl vinyl acetate actually. Ethyl vinyl acetate, that is EVA. Then solar cell, that is you can see that PN junctions. Then an encapsulant again, top as well as bottom, then backsheet and a junction box. Okay. All these materials are finally going to become, presently I can call it as e-waste. Future, I should call some S waste or something. That is solar waste or some P waste, photovoltaic waste or something. I don't know what the name government and the agencies are going to give. Now, solar panel waste to triple by 2030. Dangerous. This 2024, only 6 more years. India's current installed solar capacity is just 66.7 gigawatt. That is in the year 2022-23. Generated about 1 lakh tons of solar waste. In 2022-23 alone, 1 lakh ton of solar waste. Now, this is predicted to increase to 3,40,000 tons. That is 3 times, more than 3 times by 2030. Just 6 years. Just within just 6 years, if it is 3 times, within another 10 years, imagine how much. So more than 3 times the current level. Who will address this? Who should address? This will include about 10 kilotons of silicon, 10 kiloton of silicon, 10 to 18 tons of silver, and 16 tons of cadmium and tellurium, which are pivotal for India's this issues. Mining issues will come into picture. Now the general tool, environmental impact assessment tool. It is called EIA, environmental impact assessment. There is a tool as well as process for all engineering systems and manufacturing processes everywhere, protocols and guidelines. Similarly, for renewable energy developments also, we are using environmental impact assessment tools. Using the tools, we will address that process. One is screening. First step is called screening. The first step determines whether a renewable project requires a full EIA. First, whether requires a full EIA or not. That's the first screening. Whether requires, just like a doctor diagnosing a patient, whether should be admitted or not. That is full request, whether a full determination, that is full environmental impact assessment is required or not. This decision is based on the size. Sometimes it may be small. Location may be somewhat environmentally friendly, and the nature of the project, whether it's a large project or medium-sized project, as well as its potential environmental impacts. Again, for getting license, we should see the potential environmental impacts. If it is higher, the screening committee will reject it. Okay, just like our projects nowadays, BTech projects, below quality, we can reject. Projects that are likely to have significant environmental impacts typically proceed to the next stage of environmental impact assessment process. Otherwise, the very beginning itself, we will reject. Next, you can see scoping. That is in this stage. So first stage qualified, and it comes to second stage, the key environmental issues and the extent of the assessment required. Scoping involves determining which potential impacts are significant. Which are significant? Where it is affecting the birds, where it is affecting animal, or what is the impact? Impacts significant enough to warrant a detailed study. What is demanding? A detailed study on, say, fatality of birds, death of animals, or something, some other reason, or health issue of people, which is more significant. It sets the or EIA and focusing the assessment on the most critical environmental aspects. Other things we will neglect. Okay. Third stage is impact assessment, the core of the EIA process. This stage involves detailed studies to prediction and modeling, actually, to predict and evaluate the potential environmental impacts of the renewable energy project. And we are taking that project. What are the impacts? It covers a wide range of environmental factors, including the biodiversity of the area, water and air quality, how it affects, many industries, people suffering low quality water in many places in Indian cities due to the presence of large scale industries. So water and air quality, soil, landscape, the cultural heritage, socio-economic impacts. That's also there. Not only the environmental impacts, other two are socio and economic impacts. The assessment considers both the construction and operational phases of the project. This is the drawback of the environmental impact assessment tool as well as the procedure, because they are addressing only the impacts at the time of construction and operational phase. What about the decommissioning? Nobody is addressing, because now it's not an issue, but in future it will try to solve us. So even EIA tool should be redefined. Decommissioning process protocols also should be there. Now we'll come to mitigation and enhancement, the fourth stage of the environmental impact assessment. Based on the identified impacts, we will get a set of impacts. This stage proposes measures to avoid, either to avoid or reduce or compensate for adverse effects. Okay. Plastic, we have this policy now, RRR, is it? Reduce, recycle, reuse, and all those. Similarly, some impacts we can reduce, some we can avoid, some we can compensate from adverse effects, as well as opportunity to enhance environmental benefits. We can enhance the environmental benefits, like greenhouse gas effects. So by enhancing the environmental benefits, even if there is adverse effect, we can take a bail. So mitigation strategies might include altering the project design through a project alteration, re-option, project site change. That's why I use the word utopian environment. Okay, that's engineer's task, not the environmentalist task. So that's why engineering plays a major role here. The project design for relocation and all those, implementing protective measures by the engineers on restoring the affected areas. The affected areas, through a re-engineering process, they can process. Next, the fifth stage is environmental impact statement. Finally, an EIS, environmental impact statement, will be there. The findings of the environmental impact assessment are compiled into an environmental impact assessment or a report. For every project, this report is required. The EIS provides a comprehensive overview of the project, its potential environmental impacts, proposed mitigation measures, and the residual impacts after mitigation. It serves as the main document for decision making. Okay, when we are starting projects, we need approval from so many agencies. You know that, from electrical inspectorate, from inspectorate of chemicals and explosives, forest department, fire force, other agencies like environmental agencies, pollution control board. So from everywhere we need clearance. It serves as the main document for the decision making. Government is the decision maker. That's why government is asking all types of feasibility project report, feasibility study and report before taking a decision, and public consultation. Now the sixth one you can see, consultation and participation. That is engaging with the stakeholders. Nowadays our colleges are accredited, when our programs, not colleges, or programs are accredited. There we know the word stakeholder. Okay. Stakeholders, including the public, government agencies, the environmental organizations plays great role, both NGO and GO, government organizations as well as non-governmental. It's an integral part of this EIA process, just like our outcome-based education colleges. We are getting output from all categories. This stage involves presenting the EIS, that statement, for feedback, addressing concern. That's why government is publishing the report to public through media. Public can give comments, their concerns through feedback, and they can give the addressing the concerns. So district collectors are addressing the concern. Even when we are moving for 6-way roads, every district collector invited meeting of the public to know their concerns of the dealers, people's drivers, and all those. So addressing the concerns and incorporating the stakeholder input into the final EIS. The final one, approved one, the feedback from all category will be there. Then only the decision comes. Now the decision-making stage. The final EIS is submitted to the relevant planning authority. Government have a planning board. So submitted to the relevant planning authority. The authority may approve, sometimes may approve the project, sometimes request further information, or even refuse permission. All these three can happen. Okay, government boards, autonomous boards, there the decision comes. Now, once commissioning, the monitoring and compliance. If the project is approved, this stage involves monitoring the implementation of mitigation measures and the project's environmental performance. Whether it is as per the protocols fixed, whether it is okay, is there any problem in the environment, it is monitoring. Compliance with the environmental regulations, and next one I have marked in red, the conditions of approval is essential for the project's sustainability. You can see the word, the conditions of approval is essential for the project's sustainability. Now, think about the subject sustainable engineering in BTech. Actually, as if we are teaching as per the syllabus, there will be no use for the student other than getting some grade from the university examiner. But such practical aspects will make them fit even to attend interview properly. Now, I am addressing some 4 sources. Biomass I left, types of renewable energy and corresponding impact. Wind, that is potential for visual. Previously, I told that visual impacts due to that blade rotation, and noise, that vibration due to that vibration. Impact dependent on the number and size of turbines. Sometimes there will be 400 to 500 large turbines. Then suitability of location for wind power generation. These are the impacts. Then mini hydro is also considered as a renewable one. River flow downstream, water pollution risk, flood vulnerability, river users, waterborne disease. Waterborne disease also concerned there. Navigation, cumulative impacts, everything you should address. In geothermal energy, the impacts to thermal springs and associated flora, water pollution, visual impacts again, of such things. And finally, solar energy, largely limited to the production, okay, as well as the batteries, how we are using. Of course, biomass is there. I left that because our major concern is wind and solar energy. With this, I am closing. That is the insurance, reinsurance, their statement. Our research estimates that worldwide in 2020, that is 4 years back, offshore and offshore wind projects represented 43% of the total renewable energy investments. At the same time, solar project is below that, 39% only of the total renewable energy production scenario. Around 50%, that is 43%, is from wind energy. So extensive study is required because it may vary. Impact will be different. If I am commissioning a wind turbine in Trivandrum district, impacts are there. If I am commissioning the same thing in Idukki district, impact will be different. If I am commissioning the same thing in the state of Tamil Nadu somewhere, again impact will be different. It is regionally, impacts are regional. Now you've seen when you are commissioning in Attapadi, Palakkad, that species, rare species are affected. So region wise, the impact. So whenever a project is commissioning, there won't be any direct ready-made report with us. It varies locally. Okay. and it is now above solar projects. It's only 39% of the total. Okay. With this, I'm concluding, and I thank all the participants. I hope that you not got bored, because the subject is not absolutely pure engineering arena. Something related to humanities as well as other subjects, environmental science and all those. Okay. Coordinators. This
Participants, do you have any questions? Participants? Any questions? Okay, sir. There is no questions, no anything. So, sir, thank you, sir, for your inspiring words on environmental impact of renewable energy. Your words are truly wonderful. Thank you, sir. Thank you very much for taking this session. Thank you.
Okay, welcome. Thank you all. Thank you all participants. Thank you, coordinators.
Thank you. Okay. So, dear participants, the second session will start at 7:30 sharply. So, please stay.
Good evening. I'm Anand. Am I audible?
Yes, sir.
Can you allow me to share the presentation?
Oh, one second, sir.
Is it visible now?
Oh, okay, sir. It's visible, sir.
Okay.
No,
We can start at
One second,
7:30.
sir. One
Yeah.
second. Angela, ma'am.
Yes, sir.
Okay, we can start, ma'am.
Moving on, it's my pleasure to introduce our next esteemed resource person, Dr. Sir Anand. Thank you, sir, for taking the time to join us today. We are truly honored to have someone of your share insights with us in this session. Dr. Sir Anand currently serves as the chairman of research and studies at the Institute for Sustainable Development and Energy Studies in Shannur, Kerala. He is also a visiting faculty member at the National Power Training Institute and the Power Engineers Training and Research Center. With a rich professional background, Dr. Anand has held several key positions in KCB, including head of the state local dispatch center as chief engineer, head of state transmission utility as director, director at Renewable Power Corporation Kerala Limited. Dr. Anand earned his PhD from QSAT in 2020, and his notable achievements are the development of unitized 33 kV subtransmission system with unmanned operation and N1 security, receiving the best system operator award at the national level in both 2021 and 2015, and developing a new market operation strategy in real-time market to deliver significant commercial benefits to KCB from 2020 onwards. Additionally, Dr. Anand has authored 7 research papers in reputed journals showcasing its academic contributions to the field. Thank you once again, sir, for joining us today. We are eagerly looking forward for gaining from your expertise. Over to you, sir.
If I am audible.
Yes, sir, you are
Especially in
audible. What, sir?
In case somebody can intervene also, because well, I'm actually a faculty, so skipping fast. So a question on me to elaborate something. Okay, so we shall start. What is energy transition? Energy transition is a buzzword now. And actually, the climate change studies across the world identified a few causative agents, and the most significant among them is found to be the electricity generation and its use. But energy transition is not only electricity; it is a shift from the fossil-based sources to zero carbon sources for all energy requirements, including transportation, heating, all factory applications, and all. And our aim was to reduce, or rather to limit the temperature rise to within 1.5 degree of the pre-industrial levels, which is maybe a distant dream. And I don't know what will be happening in the present situation. Now, India had made some commitments. One is that the 500 gigawatt non-fossil fuel-based energy capacity will be added by 2030, and 50% sources by 2030. Carbon will be reduced by 45% by 2030, and 1 billion ton reduction in carbon emission by 2030, and net zero by 2070. These are the commitments given by India in the international forum. And some policy initiatives are also taken up. One is increasing the forest cover, improving energy efficiency, low carbon electricity generation. This is an area where we need to, as an electrical engineer, we need to be more concentrated upon. And integration of electricity grid, that is another aspect which has been considered. Now we are connected with other countries in the neighborhood. For example, with Nepal, Bhutan, Myanmar, Bangladesh, and probably to Sri Lanka in another couple of years. And we are also planning, and detailed project report is in preparation for connecting to Middle East, to Saudi Arabia, which may take another 5 to 6 years to complete. Now, another breakthrough was the development of green hydrogen and green ammonia to replace the fossil fuels. And green hydrogen can also be considered as a storage for electricity. Storage of electricity is something which we are now talking about. And in the transportation sector, we have already gone a way much ahead in the adoption of electric vehicles, and also blending methanol, hydrogen, IC engines, and the vehicle scrap policy are already in place. So adoption of electric vehicles is in a way, it is going on. But one catch is there, that how much is the contribution of electric vehicles to the gray power? That is a question which we have started pondering upon, because most of the vehicles are getting charged during evening hours when sun is not there. And wind is also not there during early hours. Maybe it may be there up to say 11:30, 12 in the night, but the contribution from the wind is much lesser, and our even otherwise our consumption is high. So electric vehicles are now charging not from the solar energy, most of the vehicles, but from the gray energy only. So the transportation sector, by way of adoption of electric vehicles, is not contributing much in a way to the greening of our energy requirement. Now, the major technological issues which as practicing electrical engineers, what we face is the increasing renewable energy in the grid and the new strategies for improving controllability of these resources. Because the major problem with the renewable energy, except for major hydro, with storage hydro, is that they are not much controllable, and power is available only when either sun shines or wind blows. That is the situation. And we need to promote them. So we had given some strategy, operational strategy that solar and wind should not be curtailed for any reason. It should be, whenever it is available, it should be used. But now we are going into a condition where the wind and solar generation is also to be curtailed as per the requirements. Why? We will come to that in one of the slides. So what are the non-fossil fuel sources for electricity? One is hydro, of course. It is the most beautiful thing. It has the highest controllability. The only requirement is that you need to have reservoirs to keep water cold, meeting the summer requirement. And most of the parts in India, except for North India, where glaciers are melting during summer, will be having little inflow during summer period. Whatever requirement of hydro generation is there, it has to be stored in the reservoir, the upstream reservoir. The reservoir has to be very big, and that poses another threat to the environment, maybe including climate change. So that is also limited now. The small hydro generating plants, which we are promoting in a way right now, are not contributing much to the non-fossil fuel requirement for generating electricity during summer, because most of the small hydro plants are either run-off river or with very small shortage. During summer period, there may not be water to generate. And the other sources are solar and wind. As you know, it is always available. Solar is much more predictable than wind. Wind is having the maximum variability and uncertainty. Solar is having variability, but it is quite possible that we can have much precise forecasting. Only cloud movements are there, but if you are spreading the solar across the country, then cloud movements could not be an issue, may not be an issue at all. Now the next source is nuclear. So if we are replacing, we are using coal-based energy as base, as well as for varying the generation as per the load requirement. So if you are going for nuclear against the clean energy, it's not causing much damage to the earth, to the global warming. But nuclear energy is having a problem that started right from the beginning of nuclear energy development. One is that maybe it is an apprehensive approach also, that it is considered as a baseload generation. Why? Because nuclear generators are not willing to change their generation as per demand changes. So this has led to a situation where nuclear generation may be there even if there is no requirement, and we may be forced to reduce solar or wind generation or even hydro generation to accommodate the nuclear generation. So that is posing a difficulty. And across the world, if you look, some countries where the technology, all the technologies were used, they were not able to do that. The problem with the nuclear generators is that one technical issue is there, that the nuclear neutron absorption to reduce the generation. That is causing an issue, because the heavy water normally used in the control is getting poisoned, the technical term they use. And that contaminated water has to be properly treated. So that is the problem that they are facing. But there are technologies now, the technological innovations and developments have resulted in controllable nuclear generation. And in some countries where the system operators or regulators said that either you have a controllable nuclear generation or otherwise you leave the field, force some of the nuclear generators to adapt to the requirements to some extent. But there are some cases where, like in Germany, almost all nuclear generators are scrapped because the technology was very old and they wanted to have a new nuclear generator could be much easier and controllable than modifying the older ones. So that being the condition, in India, we are now having a mix of all these things. Even Kudangulam, which you may be aware, which is a recent one. There also we don't have much controllability, but the new ones that are going to come in the next stage will be having controllability that has been captured at policy level. And other sources are wave, geothermal, etc., etc. So many sources are there in the research field, but commercial operation from these are not much possible. Geothermal is again, it is site specific. It may not be possible in all locations. And wave, the cost of generation and the quantity that can be generated is rather limited. So technology has to be developed for commercial operation of exploiting the wave energy. Electricity grid management, coming to that aspect, the generation has to be controlled and just to follow the demand in real time. That is the basic issue in grid management. It cannot be. It is a non-fact. Now, in the conventional operation, we had practically no storage, and regulation of generation as per the demand changes was the only way out. And again, electricity is the mother of all industries, and more and more energy use is being changed to the electricity. Why? Because of the controllability at the place where it is used, or the easiness in transporting the energy from one location to another. So this being the conditions, we need to optimize the cost of electricity. It has to be kept in mind that we need to promote all other industrial activities or improving the quality of life. We need to reduce the cost of electricity. So there were a lot of research work going into that, and several innovations were done. And we followed something called an optimal power flow for meeting the electricity energy requirement. And in the case of optimal power flow, we found that generating electricity where the resources are available, where coal is available. If it is a pithead station, then the coal transportation, which is much costlier than the transportation of electricity to transmission system. And that resulted in locating the generators near the pitheads, and the transmission system design, of course, followed the OPF, and that was the way in which the system was designed. And again, the most important thing was that the conventional management forecasting was required only for demand, because generation is something which is always controllable. Only issue was with maybe with run of the river hydro schemes or with nuclear stations, the contribution from these sources being comparatively much less. The controllable, the entire generation is controllable. And with a good transmission system, it is always possible that power can be better utilized. And we were doing something called CED, that is Security Constraint Economic Dispatch. Or in simple terms, it could be something like merit order dispatch, where the cost of generation from the generating station becomes the sole criteria for selecting a generating station to run at what level. So all the control centers in India, it is at national level, regional level, and state level. We have load dispatch centers, and all these load dispatch centers were always trying to see that generation from the cheapest sources are getting scheduled. This is the conventional management that we were following. Now, if you look at the figure on the left side, you can see this is the power grid, and all the schedulable generators were there, hydro power plants were there, nuclear were there, coal-based power plants were there, and traditional loads are also there. Now we are moving into a system where we are having more and more power electronic loads and more and more uh, wind power and solar power. And again, in the case of transmission, we had to transmit power across a long distance. A significant quantity had to be transferred. The development of AC network was a bit causing a bit difficulty there because of the reactive issues involved. So we had to go for high voltage DC, and we have a good network of HVDC lines also now in India, connecting different points, different nodes, right from the eastern part to the south, west. All these regions, not all these regions are interconnected with HVDC lines or back-to-back HVDC lines. And now again, now coming to the motor drives also, we have a change that we are going into variable speed drives and LED lights are there. Now we are going for BLDC fans, what you call energy efficiency methods are causing damage to the conventional system where the loads were all sinusoid and waves were going very smoothly to the equipments and were working very fine. Now we have a lot of electronic loads, means a lot of um, pollution is being done into the I said pollution, it's an electrical pollution is being done into the grid. So we need to correct that also. So that required installation of statcoms, power conditioners, power flow controllers, and all these things have now become a requirement. And most of these things have become reality in Indian grid also. Now, with the transition of electricity, the grid operation, changes in the grid operation is that one thing is that the generation to follow demand in real time, there is no change that cannot be done. We need to ensure that quality of supply is always maintained. The sources are very variable. Our resources are coming solar and wind, and the availability from these sources are not matching with the consumption pattern in real time. That is the issue that we are facing. And the new requirements are we need to have flexible operation of conventional sources and we need to have storage. So coming to storage, again, we need to provide the main requirement is during the night time, we don't have solar. And maybe in the morning hours, early morning hours, say from midnight onwards, we may be having lower quantity of wind. And again, in the off season of wind, that is also a problem. Wind is seasonal, and we had cases of 1,500 to 2,000 megawatt variation in wind generation on daily basis. That is, if compared to today's generation, tomorrow's generation or yesterday's generation is having a variation of 1,500 to 2,000 megawatt on several days in Tamil Nadu now. Tamil Nadu is a major source of wind. And in Gujarat also we have the same issue, whereas in Kerala we don't have much. We have only some 45 megawatts. So that is, again, if you take that, there is a difference of some 10 to 50 megawatt. If you take the percentage, then again it is alarming, but the quantity being very less is not a concern for us in Kerala. Karnataka also is having the same problem because they have about 7,000 megawatt wind available. So controllability, variation of wind is a real problem for them. So transition, as far as electrical engineers are concerned, is from fossil fuel to RE sources, and RE sources are not controllable and not available during the peak demand period. So it creates a deficit condition there. I'll come with the figures in another slide. So the options are partial operation of fossil fuel stations in the interim period and provision of storage for meeting the demand during low generation period. Now coming to the storage again, we need to have longer duration storage, but the possibility of using batteries for longer duration storage is rather very costly. If you go for, say, we need to think about the megawatt and megawatt hour together when we go for storage deployments. For example, if you are thinking of, say, 500 megawatt storage device, so battery energy storage system, then if it is for 1 hour, then it is okay. The cost may be in the range of, say, 5 to 6 rupees for providing the, maybe 4 to 5 rupees for providing the battery. But if you are increasing that to, say, 2 hours or 2 hours, then the cost may be increasing by 1 more rupees per unit. Effective cost of storage. Hello, the investment going into the best for providing that much relief. But if you are going for 4 hours, then the cost becomes almost 3 times. And if you are going for 6 or 7 hours, then the cost increases further. Uh, Considering the variability in the demand, which we know that during the evening peak hours, maybe starting from the evening dusk to something around 11, 10:30, 11 in the night, or even in the summer period, it may go to, say, 12:30, half an hour after midnight or 1 hour after midnight, and then the demand comes down. So if you are taking that also, for meeting the demand, what we estimate is that in the Indian context, for the entire India, we may require about 7 to 8 hours full load storage, and that is possible mainly through BESS. Through battery energy system, it may be very costly, so we need to mix some pumped storage scheme also. Pumped storage scheme per se, if you look, the cost of the capital cost involved could be something like almost comparable to BESS for about 4 hours storage. So beyond 4 hours, if you need power, then it is always economical to go for pump storage. Pump storage schemes require 2 reservoirs. One reservoir may be available with the existing plants, and another reservoir has to be provided, but that land is to be acquired, that topology has to be sufficient, suitable. Head between the 2 reservoirs and the distance between these two, they have to be within ranges. So there are some constraints in locating pumped storage schemes. So now another method which has been internationally followed is to go for microgrids. So in the case of microgrid, we are managing the system at a lower level, at a lower quantity level, where the cost of providing storage can be reduced. That is something which we have seen, and there are some other benefits also. Like if you are going for a very small system, at your home, you'll be having inverters. If you're increasing the capacity of your battery, the cost involved may be significant, but that battery system will also provide you another benefit, that whenever this transmission or distribution line goes out of service due to an interruption, then also this can provide power for the installation. But again, the limitations are there, but it can provide a lot of comfort, can provide a lot of security to the power system, and you need to provide only an additional small quantity, a marginal quantity need be provided at the grid level. So that is the way in which the microgrid management is being done now, is being attempted now. And there are several cities and several agglomerations where microgrid management is being done. I'll show you a practical case also, which has been recently commissioned. And now coming to the cost implication, when we go for solar and wind majorly, we need to have duplication of availability as such, either as storage or as an unutilized generation source during the solar hours and wind hours. I think it is clear to you. If you look at the requirement, say a particular state, say for example, Kerala is having a peak demand of 5,200, 5,400 megawatt during the evening peak hours during summer. So to meet that, we need to have that much capacity available, and solar is not available during that time. Maybe wind, we can have contracts, and internal generation, maybe something around 100 to 200 megawatt wind we can get. After that, what? So 5,000 out of the 5,500 megawatt peak demand, say if you are taking say 300 megawatt availability from wind, the 5,300 has to be met. And we'll be having water during summer, we'll be having water sufficient to generate about 1,700 megawatts. So after that, about 4,000 megawatt, 3,800 megawatt power has to be sourced from other sources. So that is creating a problem. So we need to have that much capacity available for us. But during daytime, we'll be having solar energy. So that is actually duplication of the capacity. And again, solar, maybe it's possible that we can build up solar at, see, if you are going for rooftop energy, rooftop solar, then the requirement of transmission system during daytime will be much less compared to the requirement of transmission system during non-solar hours. So this is creating another issue. Maybe I don't know whether any of you have faced it. We'll be having a problem of high voltage during daytime, and some of the solar plants in the rooftop are not working due to high voltage issues. Yeah, I don't know any of you have faced, but in Kerala it has been observed. In other states also we have observed the same thing. So that means we need to invest much more on voltage control devices, especially reactors. Earlier we were only using capacitor banks in the low voltage side. Reactors were commonly used in very high voltage, extra high voltage system only on 400 kV and above. But we need to use reactors at low voltage also to control the voltage. So that is also adding to the capex. Capital expense is going on. Now coming to the some of the figures, the statistical figures. 1947, we had an installed capacity of 1,362 megawatt, and per capita consumption was 16 units. But in 2024, the installed capacity has gone to 453 gigawatt, and per capita consumption has gone to 1,331 units. Even then, the per capita consumption in India is much less compared to its peers. Again, when you look at the per capita consumption, don't get carried away with the figures of Europe or USA, because two aspects, or even Australia, two aspects are there. We are a tropical country where the requirement of electricity, requirement of energy is slightly lower than the requirement of energy in a country in the northern or southern hemisphere. So that way our requirement could be slightly low. So we need to compare with the other countries lying in the same latitude. Now, even if you consider that our consumption pattern or standard of living is comparatively much lower than the standard of living in other developed countries. So there is enough potential for the per capita consumption to increase, and that increases without our control. As the country progresses economically, the per capita consumption will tremendously increase. So we need to provide that much energy. And now, if you look at the requirement of energy and requirement of power, as we said, we have about 435 gigawatts is the installed capacity now. But in September 2024, if you go through the lower side, the lower part of the table, the peak demand was only 230 gigawatts. And if you take for the entire period from April to September, then summer was also there. We touched almost 250 gigawatts. And in September, there was a shortage of 155 megawatt. We were not able to meet that. They were load shedding in some part of the country. And in Kerala, on some of the days we had some issues. Otherwise, in general, we don't have any shortage. Only if there is an unexpected outage, then only we'll be having problem. So the problem is now it is very clear. To meet 230 megawatt or 250 megawatt, we have 435 gigawatt. Sorry, not megawatt. 250 gigawatt power, we have about 450 gigawatt installed capacity. Why? Because the installed capacity counts the solar capacity also. Whereas the demand is mostly coming in the evening hours when sun is not there. Now, coming to the energy requirements, the position is somewhat, it is a little better because energy consumption during daytime can be met through solar. But even then, the capacity in the other sector, that is in the conventional generators, especially coal-based generators, it is being underutilized. For September, the consumption was 140,000 million units was the energy requirement, and 0.1% of the energy requirement was not met across the country. And in Kerala, we had, after taking the figures of Kerala, because of the restriction in time, in Kerala, we had almost zero shortage in terms of energy. And for the period from April to September also, we had about 0.1% shortage in terms of energy also. So this is the situation. We have to create some kind of extra capacity. And the installed capacity as on 30/9/2024, that is September end. Non-fossil fuels, you can have this details available in the CEA website, or you can have it published from my presentation. The percentage of fossil fuels in the installed capacity is 53.69%, and non-fossil fuels is 46.31%. And non-fossil fuels again include RES. RES is renewable energy sources. That is a major component with about 154 gigawatts. And nuclear is only 8,180 megawatt. And again, this is classified into, India is divided into 5 regions. And again, one more region for the islands, Lakshadweep and Andaman and Nicobar Islands. So where the grid is not connected. So coming to the hydro, we have about 46 gigawatt, 47 gigawatt, which we wanted to increase, but it is not happening. About 50 gigawatt was planned in the current scheme, but the capacity addition has not been as expected because of the environmental issues that were not foreseen in the case of the projects planned in Arunachal Pradesh and northeastern states. Now we are concentrating more on storage device, storage system, and the pump storage schemes are being planned. We are planning for about 40 gigawatt pump storage scheme, and some good progress has been achieved. And in Kerala also, we have identified about 6.5 gigawatt pump storage schemes in various reservoirs. Most of them, at least one reservoir will be using as a using the existing reservoirs, and one more reservoir may have to be constructed. And in 2-3 cases, we can go for pump storage scheme connecting 2 reservoirs, existing reservoirs itself. But as I said, the height and the distance, lateral distance, it's a problem, but it will be affecting the efficiency. Slightly low efficiency, but we can have these schemes without much requirement of what you call forest issues. Then now, if you go for the sector-wise, these figures are also given there. That coal, lignite, etc. on an all India basis. It is a figure split into region is given in the top, and total installed capacity in the country is given in the bottom. So how to schedule energy? How to plan the operation of the power system in the present situation, and what are the possibilities that we have? Conventionally, world over, nuclear is run as a baseload station. Reason I have already mentioned that coal is based as partially as base load. And again, in the case of coal, in the northern hemisphere, in the case of Europe or in USA, there is another advantage for the coal-based stations where, or even for nuclear stations where controllability can be achieved. That is for city heating. They need city heating facility by giving steam in insulated pipes. So if you have a generating station very near to inhabited areas where heating requirement is also there, part of the steam can be diverted for that, and actual generation can be reduced because the requirement of, the controllability of the generation depends on controllability of steam. If you have to maintain some steam because of the boiler constraints, then if you can divert some steam, then it is possible that you can control the generation much more. And then one of the developments that has been done across the world, and we are also doing in the same way, is to duplicate the boilers. So if you can duplicate the boilers, then if you want to reduce the generation, then what you can do is you can shut down a boiler as such. So with the existing capacity in the case of a coal-based generation, the possible reduction is almost up to 55%. We can reduce the generation, but now with some modification, the pipelines in the steam lines, it is possible that we can go to 40%, and we have already enacted a regulation that all generators should be made suitable for reducing the generation up to 40% of the installed capacity of its rated capacity. And even after that, further to 40%, if we can reduce further, then only we'll be able to get more and more solar energy. So for that purpose, what we can do is you can go for a duplicated boiler. If two boilers are running, then you'll be able to achieve the full generation. Then if one boiler is shut down, it goes to something around 50 to 55% generation capacity will be available. So with that, again, if you are reducing to something around 40%, then you can achieve almost up to 20% generation during solar hours. So that is the way in which it can be managed. And this is the same with gas also. Then gas and liquid fuel stations are more flexible than coal, but again, if you are using liquid fuels, then you are not creating much benefit because the greenhouse gas emission is almost comparable. It is not, even though it is not as much as that of coal, but there is a contribution from that. Now, hydro, we need to have flexible generation, except in the case of run-of-river stations and SHPs, we can have flexible generation facility. But again, there needs to be, in some cases, at least in Kerala also, we have a problem. In some cases, we need to have water availability for irrigation and drinking water downstream. And for irrigation, the problem is we need to have almost, continuous flow of water should be ensured, for which the generation has to be maintained during daytime also during summer period. So if you can avoid that, then it is possible. And the other problem is that when you are going for higher generation during peak hours by installing more machines. So for example, I'll come to the practical case itself. In Idiki, if you are generating continuously 780 megawatt, then even during summer, we'll be having some flooding problem in Muatuvura area. So to avoid that, what we require is we need to, and there has been a proposal to increase the Idiki generation capacity to double the capacity. So when we are doing that, during evening hours, the water discharge from Idiki will be having this effect at Muatuvura that could be flooding during early morning hours or night hours, and no water during daytime. So to avoid that, we need to have buffer storage. And in fact, we are having a small dam, but it has to be strengthened. So such investments are also going to come when we want to have much more flexibility in the operation of hydro. Other sources are quite insignificant. Whenever it is available, we can have that whatever generation is there from biogas or something. from municipal waste. Generation is there, but they are not significant to count it at the grid level. So the change is required. We have already discussed. Now we need to have that thermal fossil fuel is to be wiped off. It has to be removed. Hydro, it is limited, and other storage schemes are to be developed. And transmission system augmentation for allowing more and more variable renewable generation is to be provided with the compensations across the transmission and distribution system. So the cost impact, again, coming to the cost impact, I have already mentioned all these things that electricity cost has to be reduced to the minimum. And we are using security constrained economic dispatch, and where the generation from the sources where the cost of generation is low has to be utilized first. Then only you can go for it has to be in that ascending order of cost of generation. And again, we can go for another development also. We have already made a scheme for that, that we go for market-based economic dispatch, which is being followed in some countries. But the problem with market-based economic dispatch, the problem with security constrained economic dispatch is that when we are going for power procurement from a generating station, from where the distribution company is not having a contract or arrangement for making any payment, then we cannot take that power. The issue is that Kerala may be having, KCB may be having contract from a couple of stations there. So we have contracts with about 14 generating companies. And we can have any difference in, depending on the cost of generation, we can have any combination of generation from all these generating stations. But even then, there can be situation like Kerala is having a share from station in Karnataka near Pudiki. Pudiki is the place where it's an NDPC station. The coal is transported over there and it is being generated. So the cost of transportation adds to the cost of electricity generation. The variable cost of generation itself maybe it's about 4 rupees to 5 rupees per unit. Whereas if you generate power from a station in Jharkhand, the cost of generation could be much low. And Jharkhand may not be requiring that power during daytime. And if that power is required by Kerala it can be used to replace the generation from Pudiki, then it could be a benefit to all beneficiaries of Pudiki generating station. Kerala, Tamil Nadu, Karnataka, Andhra, Telangana, all these states will be benefited. So there we need to go for a kind of economic dispatch where the contracts are also taken into consideration. So there we go for market-based economic dispatch. Again, when you go for market-based economic dispatch, we are again going for a centralized control, and the optimization will be done at a pan-India basis. So it could be having a instead of local optima, we'll be going for global optima. That could be better, and that is being followed in several countries, and that has become a requirement of the time. Then regarding generation cost, the plant siting and economy of sizes, we have already discussed, because it is not economical regarding the economy of sizes. It is always economical for a scheme. If you go for a 2000 megawatt station, then that could be more economical compared to a 500 megawatt station in the conventional setup. And in the case of solar also, solar and wind also, if you go for higher sizes, the cost can be reduced. For instance, in Europe, in Germany, they have gone for offshore wind in a large way. Earlier, they were keeping that option as a costly one, because the installation of windmills in, especially, they have an advantage also in Caspian Sea. The depth of sea is almost 10 meters to 12 meters for a distance of about 5 to 6 kilometers from the shore. So that provides them a very good area for installing a number of windmills. So now they have gone a long way into windmill installations in Caspian Sea, because when it is going in large quantity, the transmission system cost actually reduced. Mass production reduces the cost of materials and equipment. So all this provides the economy of size. Now coming to the reduction of cost, again we need to think about optimal power flow is the most important thing. In the case of transmission and distribution, cost and appropriate compensation at the appropriate location is to be provided. And again, use of HVDC is again, it is also related to the siting of generating station. When we think about this, is one more thing is there. Suppose you want to install, say, a 100 megawatt solar plant. 100 megawatt solar plant, if you want to install in Kerala. From the utility side, if you're going for that, it may not be economical compared to developing a 100 megawatt solar plant in an area to the north of Karnataka or in Andhra Pradesh or in Rajasthan or Gujarat, where the actual generation from the solar panel, from 1 meter squared solar panel could be much more, about 10 to 15% more generation can be obtained. And again, land is also another thing. The cost of land is also another thing. So, if you go further north in Ladakh, if you can make a good investment, then it can be much more effective, because the ambient temperature is also less. The generation from the solar plant will be considerably more. So the thing is that you need to bring that power to the load centers. And that requires a lot of investment in the AC system. So we need to go for high voltage DC. And again, when we come to the lower side, even 100 megawatt generating station in Kayangulam, we have about 92 megawatt floating solar is already there. In Idiki Reservoir, we can have floating solar, but all this power has to go from these locations to the load centers somewhere in the middle of Kerala or the coastal area of Kerala. To Kochi, we need about 500 megawatts, so it has to come from Idiki. So the transmission system, again, in the case of Idiki, since we have Idiki generation, it is not a problem, but we need to have parallel transmission systems also built. So the controllability of the reactive power associated with the varying loading of the transmission system, that can be controlled to some extent by using a high voltage DC at comparatively lower voltage. When we are thinking about high voltage DC, we will always be thinking about 500 kV HVDC or 800 kV HVDC, or with the VSC technology, if you go, it could be something around 320 kV HVDC. But having a HVDC system with something like 100 kV or 80 kV to transmit something around say 200 megawatt or 100 megawatt, those systems are also being developed, and some of the prototypes are already there. Some installations have already come, and one of the commercial parlance, it is called light HVDC. So that is also another option which we are thinking about. Now coming to the typical cost, the solar generation may be costing you roughly 2 to 2.5 rupees per unit. Maybe even less than 2 rupees also. The latest tender has discovered rate less than 2 rupees also. But if you're going for a tender in Kerala for developing solar generation, the cost could be something around 3 to 3.5 rupees, basically because of the cost of land and the reduction in the actual generation. And wind again, it is costing something around 3 to 3.5, but it is justified compared to solar, because wind is available even during peak hours to some extent, and night of peak hours also to a small extent even, but it is available. And hydro for new storage type plants, it could be something around 4 to 5 rupees per unit. All these are having only one part, because the main expenditure comes in the capex, in the capital expenditure, and the recurring expenditure is much less. But coming to coal, or any liquid-based fuel generating station also, we have two components. One is with respect to the capex, and one is with respect to the fuel cost. So the tariff is also, or rather, the payment is also with respect to that. Fixed cost could be 2 to 2.5 rupees per unit, which is the compensation for the capex. And the energy charge could be rupees 1 to rupees 3. So that will be location specific. If it is a pitted station right above the coal pit, then it could be as low as rupees 1. And storage, again, it is a capex only. And it could be something around 8 rupees. And we need to have that charging current also, charging energy also. That is also taken in that. The capex could be something around 5 rupees, and a combination of wind and solar if you are using, including transmission charges and other transmission, operations charges, etc. If you take, it could be something around 3 rupees for charging. So it could be 5 plus 3, so it could be 8 rupees onwards. That will be the cost of storage. That is, these are the current figures. And transmission charges, again, it could be something around 20 paise to 50 paise in the case of conventional grid. And it can go to 1.5 rupees to 3 rupees in an RE rich condition. And when you go for non-fossil fuel based condition, that is, we are expecting by 2050 for the entire India. So in that case, it will be going further high. So transmission charges is going to increase because of the requirement of compensatory devices and high voltage DC system, which we need to install. Now, in the present situation, we have a power market. I don't know whether you are familiar with this one. We have power exchanges, and the major exchange in India is Indian Energy Exchange, IEX, and there the prices are given for each megawatt hour. So to convert it into the unit rate, per unit rate, you need to divide by 1,000. So on the left side, we have the price, and on the x-axis, we have the time from 00 hours to 24 hours. And this is the actual data that was taken on 25th March 2024. If you see that condition, see, the rate of power in the power exchange is remaining something around 3.5 rupees to 4 rupees during early morning hours. And after that, it is coming down. Here some issues are there, like the transmission system, though it is adequate, when the simultaneous transmission requirement comes, it may not be sufficient, and we may have to curtail some of the power flow, based on which even if power is available in some area, we have some, it is known that we have something called A1, A2, E1, E2. So these are the areas which has been defined in the power exchange. These are all sub-regions. A1 means, let's say, in the northeastern states, this Assam, Meghalaya, etc., we have two sub-regions, A1 and A2. In the eastern part, we have two sub-regions. Eastern part means West Bengal, Odisha, Jharkhand, and Bihar. So there we have two regions again. These sub-regions are divided again based on the issues developed during the what you call the constraints developed in the transmission system. And coming to northern, we have again we have three sub-regions. Punjab is a single region. Punjab state alone is a single region. Because power import to Punjab is having some additional issues. And again, coming to south, we have S1, S2, S3, and S3 is Kerala alone, because we are a state at the receiving end, in the end of the grid, and whatever lines are there, they are for importing power to Kerala. We don't have much generation capacity here. We don't have any surplus capacity. And again, Western region also, we have three sub-regions, and this is the market clearing price. This MCP means market clearing price. This is the market clearing price without any constraints, but with constraints, we had the lower range of, say, even up to 50 paise per unit during the daytime because power is surplus in some area, that is in N3. We have the requirement of power is much less. They don't have any way to utilize that power. So the generators were not given any schedule by the states. So the generators had to generate, so they were reducing the price. So they were operating at a very low price. And here there has been some constraint, and here it is capped at 2 rupees per unit because the requirement of power is there, but the generator located in N3 was not able to serve to this area. Now, taking away all the constraints, if there were no constraints theoretically, then the price could have been in this pattern. That is about 1 rupee per unit could have been the price during daytime when the solar is very high. And again, when it comes to the evening hours, when the solar reduces, the price increases. And during night hours, it goes to something around 3.5 to 4 rupees per unit. So this is the situation. This is the case which will happen. And this issue could be more problematic in the days to come with the increase in very VR resources, very variable renewable sources. Now, coming to the winds again, if you take this is the actual graph taken for 4 years, slightly older data, but the pattern remains the same. We have maximum capacity, percentage of wind generation. If you have say 100 megawatt availability, then we'll be getting about 80 to 85 megawatt for some time, and say maybe less than 10% of the time. And if you take the 100% time, then it could be very low. And if you take 50% of the time, then it could be something around 30%. So this is the way in which the availability from wind it can be shown. International level, it is a very typical discussion. Our load curve in the normal period is something like this one. Without renewable sources, it could be something like this one, where it can be approximated as a camel shape with a small hump, small morning peak, and a big evening peak. This is the typical consumption of electricity in any part of the country, in any part of the world, except in the very small areas where the industrial consumption is comparatively very high and domestic and commercial consumption is, except in the industrial the pattern of to this one, since we don't have much industrial and agricultural consumption. Now, what will happen if you go for generation, solar generation? In 2012, they had a condition, they had a curve like this one. In 2013, the daytime demand reduced because of rooftop generation mainly. And 2014, it came down further during daytime. And by 2020, this was coming to something around 12,000 megawatt compared to the 22,000 megawatt in 2012 during daytime. And again, the evening peak is remaining almost the same. And the problem that we will face is that with the inception of dusk, the ramping required is comparatively very high. This is the ramping. Ramping means the additional generation that has to be put on bars by the time the requirement comes. That is the main headache of a system operator. So that increased ramp is a constraint. We cannot go without that. Otherwise, we may have to shed some load here, or we'll be having some over frequency issues in this time. So this is the problem that we face always. In India, we are still having that problem. To the extent it has been solved, but even now we are experiencing sometimes, especially on holidays, with comparatively low industrial consumption. The frequency during evening hours, say from 6 p.m. to something around 5:45 to 6:15 p.m., half an hour. Sorry, 149. Now coming to a practical case, this was something which I indicated. Now suppose we have a system like that of Kerala. It's not an exact replica of the actual system requirement, but I have taken it as an example. Peak requirement could be something like 5,250 megawatt. This is being met by coal-based generation to the extent of 3,150. Hydro, we have about 1,600, nuclear 400. And again, wind, we have 100. So the total RE could be something around 2,100 megawatt. And out of that, we'll be having this, out of the 5,250, we need to have about 3,000 megawatt coal-based generation. Now, coming to the nighttime, suppose we have about 1,250 megawatt solar generation available, then hydro, nuclear cannot be controlled because it is already, we are having only older plants, so it's not controllable. So hydro can be reduced to something around 400 megawatt. Why 400? Because we have some schemes where cascaded schemes are there, like Pallivasal generating station is there in the near Muna. And below that we have a generating station Chenkula, and below we have Neriamangalam, then again Lower Periyar. Now to operate Lower Periyar or Neriamangalam or Chenkulam, we need to have water released from the Madhupate reservoir, which is through the Pallivasal generating station. So Pallivasal generating station has to run almost around the clock, because to ensure sufficient water availability in case of peak load. Next station, it has to run for a few hours extra to see that Neriamangalam and Lower Periyar are having water availability. And Neriamangalam, of course, only one reservoir is there, so we can have that water level maintained at Lower Periyar sufficiently. Say, mentioned 45% is always maintained. Neriamangalam, here, some water requirements there. Then there are some stations like where the water is going to irrigation system. If you reduce the generation, the water level in the irrigation system will not work. We have a dam. That dam is not sufficient to maintain the water. For a day, they cannot. If more water is available during evening peak hours, then that cannot be stored for the entire day. So there is a restriction on adding capacity at Peringil also. Then another case is that of Idiki. Idiki also there is a irrigation come drinking water requirement, and we need to maintain generation to the extent of something around 50-60 megawatt at the Idiki. So all these are taken into consideration in fixing that 400 megawatt, or rather 400 megawatt during daytime. And again, we have a requirement of further reducing that during night hours. Night hours in the sense after say midnight till morning peak. That time the requirement is further down. So there we need to reduce it further. All generation possible is only about 1,950 megawatts. So we have to reduce power generation from 3,150 to 1,950, which is almost 62%, or rather it implies that 38% of the capacity available is not being utilized, or we are paying for the capacity charges for maintaining the generation, which increases the cost of generation. And again, during night hours, it is further low. The demand is further low, but solar generation is not there. And we can have that 1,250 coming into the coal-based generation, because that is something which is cheaper, or rather hydro can be utilized. Hydro also, there is another constraint that hydro, the water content is also to be considered. So we have in Kerala, we have about 19 million units per day on an average capability from the all the hydro generators, and can be varied for one day. If I require, I can take say 20, 21 or 22 million units, but it has to be compensated on some other day to maintain the water availability for the remaining period of the year. So the transmission system also we have said already discussed that cost can increase up to 5x in worst case, and it has gone to 5x in developed markets in Europe and US. It has been there. And recently, I don't know whether you have noticed, there was a newspaper news item that in US, the PJM, that is the system operator there, Pennsylvania, New Jersey, Massachusetts, they were asked to bid for the transmission capability because every state wants to, every district wants to get power. So what is the rate that they can provide the constraint? And it had gone to something around 6 times the normal rate during the summer period. So that kind of extreme costs are also coming. And even with that, they are not able to evacuate the entire generation capacity, entire RE generation capacity that has come into the grid. So the generators as well as consumers have to pay more transmission charges. And generators, if they are paying, again, from where it comes, it only comes from the consumers. So the consumers have to pay more transmission charges. Now, we can take another practical case. So, it is also a hypothetical case. Now, suppose you want RTC means round the clock power. Now, suppose the rate per unit is 5 rupees per unit. For the evening peak hours, the 4 hours, you require power, but 100 megawatt you are taking on round the clock basis, or rather it is 100 megawatt into 24 hours. So 2.4 million units will be there. And the cost could be something in a 1.2 crores, 24 into 5. Then for about 20 hours, you'll be having a surplus. Now the rate we have already seen in the market is coming down during daytime. And evening hours, it is slightly more. So if you take an average, evening hours means after the evening peak hours till early in the morning. That time also you'll be having some surplus. So if you take an average rate of 3.5 for 20 hours, if you sell that power, you'll be getting 7. So the have a source providing 4 hours power alone, then 0.5 something around it goes minus and 100.4 million units. Can be the rate that can be paid for making that 4 hours power available would be something around 12.5 rupees per unit. And the storage systems that we have now with battery energy storage or with pumped storage is something around 8 rupees per unit. So it's always economical for us to go for storage devices. The deployment, of course, the capital expenditure is to be it should be the main constraint that with the implement or as funding is also being given from the government. Again, coming to that aspect, when you say that some government grants are made available for the construction of a storage station, then where does that money come from? That comes from tax component, or rather, instead of paying it for the charges of electricity that we use, we are paying it in terms of tax. So ultimately, the money is going from our pocket only. It is not coming from any other place. The same argument goes to the electricity tariff. When the government says that all and there will be no charges for up to 200 units. Some states have already given that. Where does that money come from? It is from the pocket of the common people there only. It is not coming from any other source. So there is no point in having that, what you call, from the tax and giving it to the tariff. Now, one is we have already discussed about the tariff issues. The tariff would be going high. So charging of EVs is another one. I have already mentioned that the present condition the, through the green because they are resources. Their vehicles can be charged only that in the earth. Generation by grid tie solar. Here, the issue is whenever we are going for a solar, generating much more than then the remaining energy is going into the grid and it is being see in the case of northern region, entering region, we have already seen the price of energy during daytime has gone to 50 paisa per unit. So the problem is power is available at 1 rupee per unit across the country if there were no transmission constraints, but it was not the consumers of that area, consumers of the that area were not able to make use of that low price energy because there was power generation and that is getting uh, banked with the grid. So when you are injecting into KSEB's grid, what you're doing is actually KSEB has to reduce the solar energy, sorry, coal-based energy, even after paying the capital expenses or rather fixed charges without making use of that asset. So that issue is there, and cost of energy during non-solar hours and solar hours are not equal, and demand is also lower during solar hours and higher during non-solar hours. So these are contrasting issues. So we are actually the additional cost, the cost of energy actually goes high. So is it a cost of energy? We can generate energy at a lower cost, but we are not able to do that because we need to conserve it. So the cost of preserving the earth, or rather greening of earth, that is the additional cost coming on the electricity generation. And now what we are planning is at the national level as well as at state level is more to have a from the that is by having a tariff based on taxes and recent US follow for consuming more will have price during even having a flexibility where whoever is having a but in our case there is more towards the during even there the control etc. That is where the use of smart meters is coming because the smart meters will be having information from the normally meters are communicating from the because energy meter readings are taken at the consumer level and that information is going to the meter to the consumer through the smart meter basically, and that price of energy can be taken for automatic control of other equipments like what you call if washing machine. It can be planned to be started at say 12 hours, 12 noon, so that the price of energy at that time, if it is much less, it can be made use of. Or if you have a pumping, then that pumping can be planned for daytime. Or if you have an agricultural load, it can be made during daytime. All these things can increase your consumption during daytime, where the solar can be go for more and more. Uh, what they call self-control by the. Now coming to the microgrid, just mentioned in the beginning, we have a distribution substation and we'll be having a feeder. This is the conventional thing, and in the microgrid we'll be having distributed generation all across the distribution lines. So this is the condition now, and whatever power is available, extra power if it is there, it will be coming back to the distribution substation. Now, if you have a central controller, then these things can be controlled, and even if there is a failure in this line, there will be will be having enough generation. If there is enough generation in the area, in this particular area, then even if this line is not available, this area can survive. This is the concept. And for implementing that, we need to have sufficient generation and controllability of the generator. Because if you have a line outage and your generation is exceeding your total requirement, then your frequency will naturally go high. So that has to be controlled. So all these generators have to be controlled. So we need to have connectivity from all these small generators, including solar generators, to the a central controller where the practically possible for a control of all rooftop solar generators from a central control center in even in a state, small state like Kerala. Leave a state like Tamil Nadu or Gujarat, where the number of consumers are much more. So, if you have, say, a handful of consumers, handful means maybe 1,000 or 2,000 consumers only, 10,000 or 2,000 small generators only, then it will be possible for you to control the generation with a remote facility with a central controller. So that is where the microgrid is coming up. Microgrid actually it had been developed for supplying power to distant area where the transmission and distribution system extension was not very much feasible. But now it is possible even in an apartment complex. It can be for a city part of the city. It can be done. And again, when you go for that, the cost increases because if the number of generators and the number of consumers here is much less, then the cost of providing this control center and manning that control center, or even if it is unmanned, the equipments that is required, that will be significant. So again, we need to have economy of sizes. So the concept is that we have the distributed resources, then we have the advanced power electronic interface modules and the utility grid connection. So this communication is two directional, and this is power is coming from here from the generators to the interfaces, and then it goes to the local loads. So the economics of microgrid also requires some consideration. One is that the concept is very efficient in a way that the number of interruptions of power in the microgrid area could be much less. And if you have a combined heat and power requirements, like in the case of we'll be having some industries which may require small scale industries which may require some heating directly, or even if it is a cooling requirement, it can be met with this surplus energy that is generated. So if it is a combined heat and power requirement plant, then it can be, say, a hospital or a college. The cost benefit analysis is entirely different compared to the consumption in an apartment complex, because we have daytime load available in a hospital or in a college. And again, in the case of offices, government offices, or private sector offices, the consumption will be mainly during the daytime only. And during the evening hours, there will be little consumption. But by evening hours, the commercial consumption picks up. So that kind of distribution, that kind of diversity in demand, if it is there, it can be utilized. So the CHP concept, combined heat and power concept, can be further extended if you go for a larger area, comparatively larger area, for a district, or for a part of the district, including a city area. May not be workable in purely village area because your daytime demand may not be matching, but in the suburbs and in this proper city, it can be implemented. Then storage devices at lower power level is comparatively cheaper as per the experience that we have, because as the capacity increases, the cost of storage increases exponentially. And it can provide grid support and also ancillary support for the grid, because ancillary support, what we mean is, if you have a failure of a transmission line somewhere in the system, or if you have a failure of a nuclear generator, say generating 1000 megawatt, if due to Kodangulam 1 unit is tripping due to some reason, then there is a sudden outage of 1000 megawatt coming into the grid, and the grid requires some additional support to maintain the frequency. So that can also be provided by the microgrid, because the microgrid may be having some surplus. It may be controlling the actual generation from the rooftop. And if that is also released to the grid, then the grid will be having that capability. Now, at present, what we are doing is with the hydro generation, we are doing that. And with the controlled generation from the coal-based station, we are providing that kind of support, which is called ancillary support, and it is paid also. If you are giving that support to the grid, then naturally that whoever is causing that issue has to pay for that support, whoever has given the support. Then in the event of a total outage of the system, you need to have a black start facility. If transmission outages are there or generation outages are there, then it could lead to a cascaded tripping and the entire area may go without power. So in that case, major generators have to be started, which requires auxiliary power. And there are some generators, especially hydro generators are there, and solar generators are also capable of that. Even without any power, they can start generating. And a black start facility can be extended. The microgrid should be able to come into service very easily. And frequency response can also be provided by frequency. Support for frequency response can also be provided by these. So all this can earn some money for the microgrids. It's already an established thing. So the economics of microgrid depends on this. The extra money that can be obtained from these sources also, maybe coming to something around 1 to 2% of the total expenditure that the entire expenditure for the microgrid. But even that 1 to 2% could be there to make it financially viable to some extent. And the reduced cost of storage devices also gives ample scope for promoting microgrids. And there are some misconceptions also. That is what I wanted to highlight here. By microgrids, we mean, in general parlance, we mean something like a rooftop solar panel and a simple distributed system. It cannot be considered as a microgrid. There can be cases where the microgrid can be, this particular area can sustain an outage from the power system, but that cannot be a microgrid, because microgrid needs to have a control. A single solar panel or a small number of consumers having solar panels, it cannot be considered as a microgrid. Then other small generators, say some of the industries like, for example, in Kerala, we have the Cochin refineries. They have about the total load is about 250 to 300 megawatt, that could be their demand. And they are taking only about 50 megawatt to 60 megawatt from KSEB, because they want to maintain their power at any cost. They have to maintain that the refining activities they cannot stop when power goes. So what they do is they have an internal generation, and the total internal generation, the minimum generation requirement could be something like 100 to 150 megawatts. So only the remaining portion can be taken from the grid. So this was a condition, and out of the convenience, what they did is most of the refineries, not only Cochin refinery, all the refineries in India were taking very small quantities from the local grid, and the major component of their consumption was from the internal generation, which is, of course, they have the fuel. They have petroleum is with them. So they have fuel, there is no problem for that. And that cost is also getting added to the cost of petrol and diesel that we purchase. So there was a discussion and with power system managers that we had a meeting with the petroleum ministry, and we had analyzed with some external agencies and some the institutes like IIT Mumbai and IIT Delhi. We had made an analysis and we found that it is possible for them to use at least 75% of their total requirement from the local grid, and balance 25% from the internal generation. So the point is whether that can be considered as a microgrid. Definitely no. It's not a microgrid. It's only a backup arrangement. So that is also not a microgrid. Microgrids are can be something like it can operate on 24/7 basis for the entire year without any break, with some controls also. So that is the main identity of a microgrid, where the generators are controlled, where the system is controlled, so that the demand can always, generation can always follow the demand, and demand can always be met without any reduction in quality. Now, recently, there has been a case study also in near Massachusetts. We have a Paxton Municipal Light Department. That is a local distribution licensee there. They have about 2,000 customers. And they had some battery energy storage also. And what they did is they formed a consortium with about 40 municipal utilities, and a large bus was commissioned. Large battery energy storage system was commissioned, and about 50 megawatt capacity. And there was a additional cost involved in that. About 200 million savings could be there on account of the sharing of the battery energy storage system by all these municipal utilities together. So that is a way in which the economy of sizes can be obtained. See, it is only for a municipal area. Okay, so this is a picture from that area that they have installed the energy storage that they have taken this from the renewable energy world. And so the final point is that we need to go for a smart grid where we have an energy management system, which is a replica of the present state load dispatch center or R&D's regional load dispatch center. We'll be having smaller energy management systems where we'll be having controls to energy storage, to the solar generators, to the wind generators, to the hydropower generators, and again from the rooftop also. This is also to be controlled, and that is something which has already been mandated in some of the countries in Europe. And there also, wherever the last order came in Germany, was that whoever is having rooftop solar, they need to change the solar inverter, so that it can control the generation, can control the injection to the grid, whenever the grid requirement is there, based on the signal received from the SCADA center. And whichever inverter is not complying to this one after a particular date, I think then it's about 2 years old. If that is not compliant, then that inverter has to be removed from service, and their generation, solar generation, if they want, they can have it on a self-supporting basis. That is, off-grid solar they can generate. Otherwise, on-grid, if it is to be there, then it has to comply with the requirement. So that was the it's been given by Germany. California also, there was a move like that, but I think there was some uproar over that. So finally, what happened is that the solar generation from rooftop is going uncontrolled, and uncontrolled generation means more charges because the control required at the grid level increases. So these are the concepts that are going on. So let's can go for discussions and everything. Question.